Hello students, how are you? I hope you are all doing well and you are all preparing for your entrance examinations. Okay, and I hope many of the students are waiting for the completion of board examination to give the 100% concentration on the KCET examination. Is it right or not? And for those people here, there is an opportunity. And please utilize the program and you can succeed in the entrance examination. Okay, before going to start the chapter and the explanation of the contents, let us introduce myself. Okay, myself, ನನ್ನ ಹೆಸರು M.R. Sridhar Murthy and I have experience of 14 years of teaching physics for for various classes like degree, PUC, KCET entrance examination, NEET and JEE examinations. Okay, and I am here to explain the concepts related to KCET entrance examination. Okay, in today's session we are going to discuss about the chapter. We are going to discuss about the chapter units and measurements. What are the important points we have to learn? We have to learn so that we can answer each and every question from the chapter units and the measurements in the KCET entrance examination. And if you learn these points carefully, you can easily answer any question from this chapter from the KCET examination. Okay, so let us start our class. And one request, ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ ದಯವಿಟ್ಟು ಕಮೆಂಟ್ ಮಾಡಿ. ಇಲ್ಲ, you can go through once again. We can go through once again so that it will be very clear. It will be very clear. Okay, so we start the class. So let us welcome to the session, that is units and measurements. What is before going to see what is the unit and how it is a measurement and all those things, let us understand about the idea of physical quantity. What is the meaning of this physical quantity here? Physical quantity is nothing but anything or any quantity which can be measured, anything which can be measured and expressed. Not only measured, we have to express mathematically. Here we have to express mathematically in the form of what is that? In the form of Q is equals to N into U. Is it right? So what is this Q called? Q is called as a quantity. And N is a number. N is just a number. And U is called as a unit. For example, if I want to write mass, it is a physical quantity, is it right? Mass is equals to 5 kilogram. Mass is a physical quantity. 5 is a number. Kilogram is a unit. Like this, if we measure any quantity and if we express mathematical in the form of N into U, that is called as a, we can say, physical quantity. Later, see here, this physical quantity is basically classified into two types. First one is called as fundamental quantities, and second one is called as derived quantities. Okay, what are these fundamental and derived quantities? Let us learn one by one here. Fundamental quantities are nothing but which are independent. Just I will write in one word so that we can easily understand that. Which are independent are called as fundamental quantities. For example, we can say mass, length, time, and all those things are called as fundamental quantities. And what are the derived quantities here? Which are derived from the basic or fundamental quantities. Okay, and such quantities are called as derived quantities. For example, we can go with the density. How the density is obtained here? Density is nothing but mass by volume. Is it right or not? That is, it is derived. Volume is again nothing but length into breadth into height. All are length only. Therefore, we can say work, pressure, force. These are all examples of derived quantities. And whenever we put all these quantities, that is fundamental quantities, we'll get a group of systems. We can get a group of system that is called as system of units. Before going to system of units, let us understand about unit. What is the meaning of this unit here? Unit, in the sense, unit is nothing but see here, the standard physical quantity. This is nothing but standard physical quantity used to measure, used to standard physical quantity used to measure any other quantities, any physical quantities only, not other quantities. Any physical quantity is called as what is that? Unit is called as a unit. And see here, units are again classified into two types. One is fundamental units. And the other one is called as derived units. I hope you're understanding these points. But these are all very, very basic and important points. We should never miss these things here. What are the example for the for example for this? We can say it is kilogram, meter and second. Derived quantities. Whenever we go with the derived units, the units which are depending on the fundamental units, or the units which can be derived from the fundamental units, are called as derived units. For example, see here, kg per meter cube, that is a unit of density, and it is Newton is also unit of force here. Similarly, joule is nothing but unit of work, which can be derived again from the fundamental units. What is the fundamental here? Fundamental units are nothing but the units which are independent, which do not depend on any other physical units. So let us understand, whenever we put these units together, we will get a system of units. Let us learn briefly about the system of units. What are the system of units here? Here we are having the different types of system. In that, first one is fps system. F stands for foot, P stands for pound, S stands for second. Okay, that is the fps system. So in this, we have to understand that, see here, foot is a unit used to measure length, fundamental quantity length. Pound is a unit used to measure mass, and second is a unit used to measure time. Is it right? And similarly, whenever go with the second one, we can say it is a cgs system. Is nothing but centimeter, gram and second. Centimeter used to measure length, gram used to measure mass, and second used to measure time. And third one, that is mks system. Is it right? See here, meter, it is used to measure length, kilogram used to measure what is that, mass, and second used to measure time. Is it? These are the three different types of a system. Now, after the discovery of electron, people came to know that many fundamental quantities are required, along with mass, length and time. And including those quantities, we have framed that is a system called as SI system. Is it right, ma? So internationally accepted system. Is it right? So in this system consists of the two things. We can say seven supplementary quantities. SI system consists of seven supplementary quantities, and we can say two. Sorry, seven fundamental quantities. Here, fundamental quantities. Seven fundamental quantities, and also we can say it is two supplementary quantities. Okay, so that is about the information about the thing here. Two supplementary quantities, fundamental and supplementary quantity. What are they? Let us have a look over this here. So whenever we go with the fundamental quantities, first one, we can say it is mass. We can say it is a mass, measured in the unit kilogram, represented by the symbol kilogram. Is it right? Kg. Length is the quantity which is measured by the unit meter, represented by the symbol m. Is it right? Similarly, whenever we go with the next fundamental quantity, time. Time is measured in the unit second, represented by the symbol s. In the same manner, whenever we go with the further quantity, that is electric current, electric current is measured by the unit ampere, denoted by capital letter A. In the same manner, what is the temperature? What is the temperature? Measured in the unit Kelvin, measured in the unit Kelvin, represented by the symbol capital letter K. And similarly, what is the luminous intensity here? Luminous intensity. Is it right? So it is measured in the unit candela, represented by the symbol CD. And finally, we can say that amount of substance. Okay. So what is the unit to use it to measure the amount of substance? It is mole. It is a mole, and the symbol is MOL. This is about the fundamental quantities, and we can say, and the units and the representation of symbols to represent the unit. Now whenever we go with the supplementary quantities here, so there are two supplementary quantities. First one, we can say it is a plane angle. We can say it is a plane angle, denoted by the symbol theta. So how can we define, or how can we measure this plane angle? Observe this. Whenever we consider an arc, the arc will have a center. Is it right or not? And the center will have a radius. If you measure the distance from the center to the arc, that is nothing but radius. Therefore, if we measure the angle subtended by the arc at the center, it is called plane angle. So how can we measure this plane angle here? Plane angle is measured by the ratio of length of the arc divided by radius of the arc. What is this L called here? L is called as the length of the arc. What is the SI unit of this here? SI unit is radian, and symbol we can say RAD. This is SI unit of plane angle. So similarly, we can also measure what is the other supplementary quantity, that is called as a solid angle. And please remember that plane angle is a two-dimensional quantity, and what is that? The solid angle is called as a three-dimensional quantity. So let us see the next one here. It is a solid angle. What is solid angle? Observe the diagram carefully. So whenever we consider the surface like this here, whenever we consider the surface like this, let us say the area of the surface is there. Whenever we consider the surface, definitely there will be some area. Is it right? And this surface will subtend an angle. Is it right? At the center, and that angle is called as a solid angle. And how can we measure this? Means, see here, if dA, what is the dA called here? dA is nothing but area of the surface. R, what is R called here? R is the radius of the surface. Then we can write d omega is nothing but dA divided by r square. That is the ratio of area of the surface to the square of the radius. What is the SI unit here? What is the SI unit? SI unit is nothing but steradian, denoted by SR. That is the symbol used to represent steradian unit. I hope you understood these points. These are the things which you have to understand under the concept of units. ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದೆ ಅಂತಂದ್ರೆ ಇನ್ನೂ ಒಂದ್ಸರಿ ಹೋಗಿ ಇನ್ನೊಂದ್ಸರಿ ರಿವೈಸ್ ಮಾಡಿ, ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಎ ಲಾಟ್. ಓಕೆ, so let us understand the next concept, measurement. What is this measurement? What is this measurement? If we go with the measurement, we can say that the process of comparing, the process of comparing a physical quantity, the process of comparing a physical quantity with a standard, which is nothing but unit, which is nothing but a unit, that is called as measurement, that is called as a measurement. So whenever we go with the measurement, we have to concentrate mainly on parallax method. What is parallax method here? The method used to determine, used to measure very distant objects, very distant, very large distances, we can say simply large distances. The method used to measure very large distances is called as what is that? Parallax method. So in that we have to understand what is the meaning of parallax. What is meaning of parallax? Parallax is nothing but, see here, the apparent change in the position of an object, the apparent change in the position of an object, apparent change in the position of an object with respect to its background, when it is seen, from from two points of observation, so see here, whenever we see this finger with two different eyes, then we can say, or we can observe that there will be change in the position of this object with respect to its background, and that is called as parallax. That is called as a parallax. Is it right? So see here, let us say this is an object. Denoted by the symbol O, O, and let us say this is a background. If I observe, we have observed this object from the 2 points. Let us say this is A and this is B. Otherwise, I will use the symbols P and Q. Q. Is it right? So whenever I observe this object from the point P, it appears to be somewhere here. And whenever you observe the object O from the point Q, it appears somewhere here. Is it right or not? And see here, this object is making an angle, with the 2 points of observation. And that theta is called as angle of parallax. Here, angle of parallax. Otherwise, we can also call it as parallactic angle. So see here, we can say if B is the basis. What is the meaning of basis here? Basis is nothing but the distance between the 2 points of observation. And if we represent capital D is the distance between the object and the points of observation. See here, capital D is the distance. Capital D is the distance between the object, and what is the points of observation. Then we can write the relation. That is theta is equals to B divided by capital D. Or distance of a distant object will also be written as B by theta. Is it right? So like that we have to think and we have to analyze. Usually we can say that parallactic angle is measured in the unit arc second. What is the value of this arc second? Actually nimge angle is measured in radian, SI unit, but parallactic angle is measured in arc second. So see here, we can say that 1 arc second symbol is always equals to 4.8 into 10 to the power of minus 6 radians. We have to keep this value for conversion of the arc second into SI unit radians. Later we have to understand about the concept, that is dimensions, Mahir. What are these dimensions? Dimensions are nothing but the power, nothing but the powers to which, the powers to which the the powers to which the basic quantities are raised to represent a physical quantity, that is called as a dimension, suppose see here, for example, if I want to represent the force, and please remember my words, if you want to write the dimensional formula of any physical quantity, first we should understand how the quantity is related with the fundamental quantities, or what is the unit, SI unit of that quantity. For example, see here, if I say what is the force, force is measured in the unit kg meter per second square. Is it right or not? So what is the dimensional formula for this? Means we can say kg, nothing but mass, m to the power of 1, meter, nothing but length to the power of 1, time to the power of minus 2. Is it right? And these powers are there, no? 1 minus 2, that those are called as a dimension, the dimension. See here, the force has the dimension for mass to the power 1, length to the power 1, so time to the dimension of minus 2. Like that we have to think and we have to analyze here. So based on this, how can you represent, how can we write dimensional formula? We must know the unit. Whenever we know the unit, or whenever we know how a physical quantity depending on the fundamental, then only it is possible to understand and to write the dimensional formula. Density nothing but, see here, kg per meter cube. Is it right? Kg m power 1 L power minus 3 we can write. Similarly, whenever we go with the work, its unit is kg meter square per second square. So we can write m power 1 L power 2 T power minus 2, T power minus 2. So similarly, if I know the unit, based on the unit, we can write the dimensional formula for any physical quantity. And whenever you refer, what is that, NCRT textbook, in the appendix, last pages appendix, whenever you see that there is a list of fundamental quantities, how they are related to list of various physical quantities, how they are related to fundamental, what is the formula and what is the dimensional formula. You please go through it, refer it, it helps you a lot. Now let us understand what is the principle of homogeneity. It's a very, very important here. Principle of homogeneity. ಏನ್ ಹೇಳುತ್ತಿದು ಅಂತಂದಾಗ ನೋಡಿ ಇಲ್ಲಿ, we can say that if a physical, or we can say, in a physical equation, all the terms must possess the same dimensions. Is it right? Or we can also say that the physical quantities are the quantities which have the same dimension, which have the same dimensions can be added or subtracted. Okay, that is called what is that, principle of homogeneity. So what is the meaning of that? For example, if I take force is equals to mass into acceleration, then according to principle of homogeneity, we can say dimensions of the force must be equal to dimensions of the product of mass and acceleration. So what are the applications of this? What are the applications, or what are the uses of this dimensional analysis? First one, we can say to check the correctness of the equation. Whenever an equation is given to you, when an equation is given to you and we have to find whether the equation is correct or not, then we can go with the dimensional analysis. Okay, and second one we can say to convert a unit, to convert a unit from one system to another system, from one system to another system, from one system to another system. Is it right? So that is also one of the unit, but we can use this formula n1 u1 is equals to n2 u2. But whenever we my suggestion is whenever we are going to convert the unit from one system to another system, directly we can go according to the units only, according to units. And see here, third one we can say to derive the relation various physical quantities, to derive the relation between various physical quantities, okay. So like that we can go with the applications of dimensional analysis. I hope you understood these things, Mahir. You understood these things. But whenever we are going to solve the numerical problems, then you will get an idea how can we apply these principles or these uses in solving the numerical problems or in analyzing the questions or MCQs. Okay, so before that, my request is to learn and to understand each and every point which are discussing under the synopsis. ಮಾಡ್ತಿರಲ್ವಾ, ಓದ್ತಿರಲ್ವಾ? I hope you can do this, you can do this. So let us move on to the next concept. Next concept, that is error, that is errors. Here, what are these errors? What are these errors? Errors are nothing but the mistake in the measurement of a physical quantity, the mistake in the measurement of physical quantity, in the measurement of physical quantity, we call it as error, is called as a error. Okay, so see here, basically errors are classified into two types. One is based on what is it, a cause, based on the cause. We are having the first one, that is systematic error, and the second one is called as random error. And based on magnitude, how much is the value? Based on the magnitude, we can say first one, we can say it is absolute error. We can say absolute error. First one, it is absolute error. And second one we can go with what is the mean absolute error. And third one, we can say that it is what is the fractional error, or it is also called as relative error. And fourth one, we can say it is percentage error. That means the error which is expressed in the form of percentage. Relative error expressed in the percentage is called as percentage error. Nodi, based on these two types of errors, we can expect the problems maximum to maximum based on these things here. So in finding the absolute error, mean absolute error, relative error, and percentage error, we can expect more number of questions. Let us see that one by one. If a1 comma a2 comma a3 comma so on an are measured values, okay, of a physical quantity in n number of trials. ಯಾವುದಾದ್ರೂ ಒಂದು ಕ್ವಾಂಟಿಟಿ ನಾವು ತಗೊಳ್ತೀವಿ, ಆ ಕ್ವಾಂಟಿಟಿನ n ನಂಬರ್ ಆಫ್ ಟ್ರಯಲ್ಸ್ ಅಲ್ಲಿ ನಾವು ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಅವಾಗ ಒಂದೊಂದು ಟ್ರಯಲ್ ಬರತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂನ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ದೀಸ್ ಥಿಂಗ್ಸ್ ಹಿಯರ್. ದೆನ್ ವಾಟ್ ಈಸ್ ಇಟ್ಸ್ ಟ್ರೂ ವ್ಯಾಲ್ಯೂ? ಟ್ರೂ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ಏನು? ಇಲ್ಲ ಅಂತಂದ್ರೆ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಆರ್ ಅಬ್ಸಲ್ಯೂಟ್ ವ್ಯಾಲ್ಯೂ. ವಿ ಕ್ಯಾನ್ ಸೇ a mean is equals to a1 plus a2 plus so on an divided by n. We can write like this here. First we have to calculate what is the mean value or absolute value. Later, what is this absolute error? What is this absolute error here? How can we calculate this absolute error? See here, suppose if I want to know what is the error in the first trial, we can say A1 minus A mean. We have to take only magnitude. If we get the error negative, then we should not consider the negative value, because errors are always be positive and always be added, okay. So similarly, what is the delta A2, the error, absolute error in the second trial, that is A2 minus A mean. Similarly, we can say delta AN is equals to AN minus A mean. Like this, we have to find out what is the absolute errors in each and every trial. Now let us go with what is the mean absolute error. It is nothing but the average. It is nothing but the average of all the absolute errors. See here, we have to consider only magnitude. We should not take negative sign. We should not include the negative sign. Okay. And delta A3 plus so on plus delta AN divided by n. This is how we can calculate what is the mean absolute error. And here I will make a note. What is that note means? Any measurement can be written as see here, A is equals to A mean plus or minus delta A. So like that, we have to write any measurement. For example, we can say resistance of a resistor is always be written as, see here, 50 plus or minus zero point 0.1 ohm, zero point 0.1 ohm. Is it right? 50 represents the real value or mean value of the resistance, and zero point 0.1 represent what is the error in the measurement of the resistance. Like that, we have to think and we have to analyze the meaning and the symbol artha. Like that, we have to go with the next concept, that is what is the relative error. So see here, observe this value here, relative error, or we can also call it as a fractional error. Relative error is nothing but the ratio of mean absolute error to its mean value. Ratio of mean absolute error to its mean value. That is called as relative error. Later we can understand about what is the percentage error. So what is the percentage error? We can say here, see here, percentage error, that is the relative error expressed in percentage is called as percentage error. It's a very, very important formulas, basic formulas. You have to learn and you have to practice. Then only we can solve the problems. Then only it is possible to analyze the questions and in order to solve the problems. So let us move on to the next concept, that is combination of errors. Here, next combination of errors. Say why we have to and go with the combination of errors. See here, for example, if we want to measure the density of an object, so we have to make four measurements. One is measurement of mass, measurement of volume. Volume again indicates the length, breadth, and height. Is it right? So if we want to measure the density, we should take the measurement of four different physical quantities. So in each and every physical quantity, in each and every measurement, I will get an error. Error. So which error to be considered? So to avoid that confusion, we'll go with the combination of errors. Okay. So let us understand one by one. So first one, we can say that error in sum or difference. ಸೊ ನೋಡಿ ಇವೆಲ್ಲ ನಿಮಗೆ ಯಾವಾಗ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತಂದಾಗ, ವೆನೆವರ್ ವಿ ಅಪ್ಲೈ ದಿಸ್ ಫಾರ್ಮುಲಾಸ್ to solve the numerical, to solve the numerical. So see here, if I consider the two physical quantities, and whenever we add, we'll get a third quantity. Whenever we add a third quantity, or whenever we subtract, then also we'll get a result, the result. Therefore we can say that, see here, delta z by z can be written as no, sorry, addition. No, we can say the mean absolute error in the result is always equal to the sum of the mean absolute error in the individual quantities, even though if we subtract the two quantities, the errors must be added. Please underline in your mind. Okay, ಸೊ ತುಂಬಾ ಜನ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಾರೆ, ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ನಾವು ಮೈನಸ್ ಬರಿಬೇಕು ಅಂತ ಅಂದ್ಬಿಟ್ಟು. ನೋ ನೀಡ್. ಸೊ ಆಡ್ ಮಾಡಿದ್ರು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರು ನೀವು ಎರರ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಸಮ್ ಮಾತ್ರ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಸಿಮಿಲರ್ಲಿ ವೆನೆವರ್ ವಿ ಗೆಟ್ ಸೆಕೆಂಡ್ ಒನ್, ಸಿ ಹಿಯರ್ the error in the product or quotient. So see here, how can we get here? So let us consider the two quantities A and B. If I divide A by B, then I will get a quotient, or if I multiply A and B, then I will get a product. Is it right or not? Either the two quantities are multiplied or two quantities are divided, then we will get, see here, delta z by z, that is relative error is always be equal to, see here, delta a by a plus delta b by b. Delta a by a plus delta b by b, that is the relative error in the product or in the quotient is always be equal to the sum of the relative errors in the individual quantities. And later we can go with see here, error in exponential form. For example, see here, it is very very important ma. ತುಂಬಾ ಸರಿ ರಿಪೀಟೆಡ್ ಆಗಿ ಇದರ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಬಂದಿದೆ, ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಂದಿದೆ. ಸೊ ಸಿ ಹಿಯರ್, ವೆನೆವರ್ ವಿ ರೈಟ್ ಎ ಕ್ವಾಂಟಿಟಿ, ದಟ್ ಈಸ್ a to the power of b to the power of q divided by c to the power of r and d to the power of s. That means if a physical quantity is written in this form, then how to write the error? See here, delta z by z, that is relative error in a physical quantity or in the product or in the result, always be equal to, see here, p times power into the relative error of the individual quantity plus q into the relative error in the b plus r into delta c by c plus s into delta d by d. Like that we have to write the relative error in the exponential form. ಸ್ವಲ್ಪ ಜನ ಅತಿ ಬುದ್ಧಿವಂತಿಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಏನು ಅಂತ ನೋಡಿ, ಇಲ್ಲಿ ಕೆಳಗೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಸಿ ಪವರ್ ಆರ್ ಇದೆ, ಮೇಲೆ ಹೋದ್ರೆ ಮೈನಸ್ ಆರ್ ಬರುತ್ತಲ್ವಾ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ಮೈನಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಬಟ್ ಇಟ್ ಶುಡ್ ನಾಟ್ ಸಬ್ಟ್ರಾಕ್ಟ್. errors always be added. Is it clear? I hope you can understand each and every point. Now let us go with the next concept, that is nothing but significant figures. What is significant figures? How can we define the significant figures? Is nothing but the sum, sum, the sum of certain and uncertain digits. The sum of certain and uncertain digits, okay, are called, or it is called, ಅಂತಾನೆ ಬರೆಯೋಣ, is called significant figures. ಗೊತ್ತಾಗಿದೆ ಅಲ್ವಾ? ಸೊ ಪ್ಲೀಸ್ ಮೇಕ್ ಎ ನೋಟ್. Just we have to learn the rules to identify the number of significant figures. Just I will explain each and every rule through an example. See here, first one we can say, if a number 784, if I take a number 784, that is all non-zero digits are significant. So we can say it is number of significant figures is 3 ಅಂತ ನಾವು ಹೇಳಬಹುದು. And second one we can say that, see here, 75800 is there, no? That means the terminal zeros are not significant. Therefore we can write this as number of significant figures in this is also equal to how much ma? Only 3. And third one we can say, if I take 605089, that means see here, the zeros between the two non-zero digits are significant. Therefore, how many significant figures are there in this number? If we calculate, then we'll get six significant figures. Similarly, whenever we go with the fourth rule, what is that? Suppose, see here, whenever we consider 280.000 like this, here, the terminal zeros after a decimal point are always significant. Therefore, how many significant figures are there in this number? Calculate, you will get so this is also a significant only, because after this zero there is a decimal point, is it right? Therefore we can say six significant figures. This is the rule number 4. So similarly, whenever we go with the next one, that is for a number less than 0, for a number less than 0, the zeros after a decimal point before a non-zero digit are not significant. So how many significant figures are there in this number? We can say it is only 3 significant figures. Similarly, whenever we express, see here, 2.89 into 10 to the power of 6. So whenever we write a number in exponential form, then also we can say, see here, how many significant figures are there? There are only 3 significant figures, and we should not consider the zeros which are added by this exponential value. Is it clear? I hope you are understanding these points, here. And similarly, whenever we go with the seventh rule, that is, for example, if I say that, see here, 28.009080 here. So observe Madi. See the zeros which are lying in between the two non-zero digits, and also the trailing zeros after a decimal point are always significant. Therefore, what is the significant figures in this number? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it right or not? 9 significant figures are there in the given number. So whenever we go to little bit high level, the they will ask the question. They will ask the questions based on addition of two numbers, or the multiplication of two numbers. So see here, eighth rule. See here, in addition or subtraction, the result should retain the number of decimal places. We have to underline this here. We have to concentrate on number of decimal places equal to a number with least decimal places Is it clear? I hope you understood this part. So what, for example, whenever we add 6.1 plus 3.435. So whenever we add this number, then how much we'll get it? So please check it here. Add madi 5 and this is 3 and this is again 5 plus point 9, 9.535. You will get it. But how to write the result? How to write the result? Final result. How can we express the final result? Which can be written as, see here. So whenever we consider the two numbers which are given to us, in the given two numbers, the first number, that is 6.1, is having only one decimal place. One decimal place. Is it right or not? Therefore, we can write the result up to only one decimal place. That is equal to how much we'll get here? 9.5. 9.5. Is it clear? I hope you understood this. I hope you understood this. Similarly, whenever we go with the next rule, that is in multiplication or division, the result should the result should retain the result should retain the significant figures. ಅರ್ಥ ಮಾಡ್ತಾ ಇದೆಯಲ್ಲ? ಯಾವಾಗ ಆ್ಯಡ್ ಮಾಡ್ತೀವೋ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀವೋ ಇವಾಗ ನಾವು ಡೆಸಿಮಲ್ ಪ್ಲೇಸಸ್ ಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕು. ಅದೇ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಡಿವಿಷನ್ ಮಾಡಿದ್ದಾಗ ವಿ ಹ್ಯಾವ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ವಾಟ್ ಇಸ್ ದ significant figures equal to the number with least significant figures. So we can give an example for that also. We can say that ಏನ್ ಹೇಳ್ಬೋದು ನಾವಿಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಅಂತಂದಾಗ we can say 2.1 into 44. If we do it 44, 444, let's say that 444, and if we multiply this value, how much will get it? We will get the value nearly, it is equals to 932.4. But how can we express this result? For that, I have to remember this rule. What is that rule here? We have to concentrate on the given numbers having the least significant figures. Among the two given numbers, 2.1 is a number having only two significant figures. Then we have to express this value up to only two significant figures. Then how can we do this? So please observe that we can write this value as the 9.3 into 10 to the power of 2. 10 to the power of 2. Is it right? Like that, we have to remember and we have to understand the rule to identify the significant figures. Is it right? So these are the points which we have to learn. And finally, we can go with the rounding of the digit. I will go through an example here. For example, if a number or if a digit which is to be eliminated or which is to be dropped, for example, say here 4.789. I want to drop this digit 9. So see here, I want to check this 9 is greater than 5. Is it right? And therefore, its preceding number should be increased by 1 unit. So we can write this as 4.79. So similarly, if the number 784 is there, I want to drop this 4. 4. So I want to observe this number, which is since it is less than 5, I want to drop it simply. So we can write this as observe ಮಾಡಿ 4.78. Is it clear? So similarly, if a number to be dropped is exactly equal to 5, I am explain one more example here. See here, 4.785. The number to be dropped is exactly equal to 5. Then we have to observe its preceding digit. If it is even, preceding digit is even, then drop this number simply. Then we can write the final answer as 78. So here if the number is 775, observe this, it is odd. Preceding digit. If the preceding digit is even, I will write my here. So if it is odd, then we have to increase the preceding digit by 1. Then how to write this? We'll get 4.78. If the preceding digit, if the preceding digit is odd, like that we have to think and we have to analyze each and every point in order to solve the numerical problems. I hope you all understood these problems, and please go through it once again, practice the formulas as many times as possible before starting to solve the numerical problem. Okay, so these are the concepts which we have to understand in the chapter units and measurements. I hope you understood this. I understood this. Is it clear? So we'll meet you in the next video with solving the numerical problem. But before that, I always request you to practice the formulas as many times as possible. I hope we'll do this. We'll do this. We'll meet you in the next video. Until then, please take care and please prepare. Don't waste the time. Thank you. Thank you very much.